Hi everyone, I'm Kelly. I'm one of your TAs this semester for CS 6340 Software Analysis. And in this video, I'm going to give a brief introduction to our lab on basic fuzzing framework. So first I'm going to go ahead and share my screen. Okay, so this is the Canvas homepage. All of our assignments and tests are going to be hosted on Canvas. So to get to lab 1, you're going to want to, or to get to the lab, you're going to click on the Assignments tab. This semester it's lab 1. It might not always be if you're watching this a different semester. Click on the one that says Basic Fuzzing Framework. And then once you're in the lab, you'll see 2 different files for you to download. One of them is a PDF file of instructions, and one is a zip file of some different files you'll need to run the lab. So first, let's go ahead and take a look at the instructions. And here you can see it says the corresponding lecture is lesson 3 on random testing. So if you haven't watched this yet, I would highly recommend doing so before you start the lab because it's going to make a lot more sense, and the terminology, you'll know what it all means. So the goal of this lab is to gain familiarity with random testing and get some hands-on experience with a fuzzing tool used in industry. And the one we're going to be using is CERT's Basic Fuzzing Framework, or BFF tool, to fuzz Linux applications, and one C++ application that we give you. So what BFF does is it targets applications that take files as input by mutating a set of seed files, and then it uses those seed files to probe for errors in handling improperly formatted or corrupted files. And in particular, it's looking at errors that could present a security vulnerability, and BFF will label this, as we'll see going through the lab. So first, the resource section, there's 2 different links. One tells you some more about BFF, and then one is about PNM norm, which is the Linux utility that we're going to be fuzzing. So you'll want to read that to make sure you know how to run it properly. And the synopsis section just gives you some general steps to take when running a fuzzer. And first, it's important you have to decide upon the proper tool to use and the configuration. For this lab, we've already selected BFF, so you don't have to worry about what tool to use, but you do have to worry about using the proper configuration. And then your next step will be to set up the program to be tested. And that includes determining what command and arguments you have to use to run the program and picking appropriate seed files. We've already given you the seed files, so you don't have to do that part, but you will have to set up the proper command and arguments. And then the third step is to process the results to isolate and fix the bugs. Again, in this lab, you're not going to actually have to fix any of the bugs, but you will have to isolate them in part 2 and kind of write about how you could fix them. But we don't expect you to update the C++ file and fix any bugs. So for the setup, BFF is pre-installed on the course VM. You'll just have to download, import, and start the VM to begin the lab. So if you haven't already done this, get that from the syllabus. It takes a while to download, so the sooner you start, the better. And then there's a little bit of setup on the VM before we really get started. In general, fuzzers usually give us different kinds of debug information, such as minimized test cases, call stack information, or memory state information. For this lab, we're focusing on minimization. So we're going to turn off the Valgrind option that's turned on in the pre-installed version of BFF. So what this is basically it's a memory analysis tool, and it causes a large performance hit on the VM. So we're going to turn it off so it runs a lot faster. And it also gives you a lot of extra input that you don't really need to look at. And in the past, students have found this a little bit confusing. So we're focusing on the GDB output in the lab, which we'll get to later. We won't worry about these. So to turn this off, we're going to log into our VM. Just a little bit slow today. Okay, and then you're going to CD into your BFF configs directory. And within this, you'll see a BFF YAML. And this is the configuration file that it's pretty much, this is the main file that you're going to be editing. it controls the entire fuzzing campaign. So you can edit this however you want. I'm using the command line VI. And at the very bottom, you'll see an option that says use Valgrind set to true. We're just going to turn this to false. And that's mostly to speed things up. It can run a little bit slow on the VM. And then the second thing that you need to do is, I mentioned earlier, the BFF zip on Canvas. Make sure you download this and put it in the home directory here. And then we're just going to unzip it. And here you can see it has given us one C++ file and then a couple different CSV files, which are our seed files that the campaign is going to use. So we're going to go ahead and cd into the CSV parser directory. You see this C++ file, and then in the instructions, there's a clang ++ command that we're going to go ahead and compile this so it's an executable that we can fuzz later in the lab. So if you're using copy paste straight from the PDF, it can be a little bit weird with the output. If there's a space copied over between the O and the hyphen, make sure you delete that or you're going to get some weird errors. So we're going to go ahead and run this, and it'll take a minute to compile the file. Okay, and then once it's done, you'll see that there's a CSV parser that's an executable file. This is all you need to do for right now. And now there's the instructions for this demo are in the lab, so I would recommend that you follow along or do this later. But I'm going to go ahead and kind of walk you through it so you can see how BFF in general works. So going back to our YAML file, there's a couple different things that you're going to want to change. First is this campaign ID. You have two parts of this. One is like the main name, and this one it's convert. We're going to be fuzzing an ImageMagick utility. And then the second part of this is a version number. So if you want to keep your different runs of the tool separate, you'll get a better idea of this later. You can keep increasing this number here, and it'll create a different folder. So basically what's going to happen is once you run the campaign, all your results are going to go into a folder called convert_B520. And if you increase that on a later run, it'll be 521, and you can keep all your files separate. So I'd recommend kind of reading through all the comments in general for this file to get a good understanding of what it does. The next section is the program that you're going to be running, and our program is called Convert. You'll be running like the PNM norm, like I said, in the CSV parser. And then the command line template. And this is something that you're going to have to change. This is the correct format for the program, which is here, convert, and then the seed file, which will specify where these are coming from later. It's going to replace it with a proper seed file when it runs, but you'll have to update the correct arguments here. And then here's where it's picking up the different seed file options from. And this is seed files examples. So if we look at that, we have a couple different, excuse me, a couple different directories here. Examples is the one that we're going to be using for our demo, and then the PNM examples are what you're going to use for PNM norm. You don't need to worry about the PDF examples for this lab. And then the CSV examples are the CSV files that you'll be using for part 3. So if we look into the examples directory, we'll see a bunch of different files. And this is what the program is going to pick up and try to test against. And then the working directory, this is just a temporary directory. You don't need to worry about changing that. And the results directory is where it's going to create that convert 520 directory that I talked about earlier inside of that once you're done. And then I'm not going to really go through these sections. You can read the comments. of what they do. The other major section that you're going to want to look at is this fuzzer options. You can only choose one for each campaign, but you want to think about which one would be best for each campaign. And it kind of tells you, these are the ones that change the input in various ways. And the descriptions will tell you, like byte mute replaces bytes with random values, or swaps adjacent bytes. So for this demo, we're just going to try the byte mute or byte mutation, which replaces the bytes with random values. So let's go ahead and run this. So from your BFF directory, there's a batch.sh, so you just need to run that. And then you can see it's adding the different seed files to the set for running. And then it's going to start picking up different seed files. And it kind of renames them to a different name. And it keeps running. And we're just going to kind of wait until we see a crash. So this could take 5 or 10 minutes. It could take longer. The time isn't as important. You're mostly going to want to make sure that you see. Or it looks like this one's actually really fast. Sometimes it'll take longer, and that's fine. You just want to make sure that you're seeing some crashes. And eventually the crashes will start repeating themselves, so you can stop it with Control-C. So for this time, we can see this is a crash ID, and it's telling you that it's found something. We'll let it run for a little bit longer and see if it finds anything else. So all of this output up here was for one bug. And then once it's done processing for the bug, it just starts going back for more seed files until it sees if it finds anything else. In your case, you're probably eventually going to want to stop the utility. If you have a small set of seed files, it can eventually run out and then it will finish. So it looks like we found a second bug here. So once it finishes with this debug output, we'll go ahead and kill it and look at the results. Okay, so it's back to the seed file, so I'm going to go ahead and Control-C to stop the run. And then in the results directory, as I said, there's the convert 520 directory now. There's a couple different things. The BFF YAML, this is just a copy of the campaign file that you used. So it's easy to check like which fuzzer you selected if you make sure to create unique folders for each run. And then there's a seed files directory, which has all the seed files used during fuzzing. The file that you're going to be, one of the files you'll be most interested in is the unique log.txt. And this has the unique crash IDs, which is how you can tell if it's a different bug or if it's reporting the same one or same crash. So these are the IDs that you'll be looking for, and you'll be turning in these outputs for the PNM norm file, or PNM norm utility. So this tells you that it found 2 unique crash IDs. And within the crashers directory, we see two different directories. One's called probably not exploitable and unknown. And this is what I was talking about earlier when I said that BFF will label them based on their expected like security vulnerabilities. So it doesn't know about one of the crashes, but the other one it thinks is probably not exploitable. So we'll go into let's go into the probably not exploitable directory. And you'll see this matches one of the crash IDs that we saw in the unique log.txt. The other crash ID will be under the unknown directory. So we're going to cd into that directory. And there's a bunch of files here. We see a JBig file, which is a type of image file, and then this is basically the seed file that it started off with. And then there's a minimized version of the seed file. And it might be the same size, that's okay. If that's the smallest one that'll trigger the error, then that's still the minimized one. So for PNM norm, this is also the type of file that you're going to be looking for. It won't be a JBig extension, but it will have the minimized in the name, and it will be the one that is similar to the seed file. It won't be like the GDB or standard error. These, if you look at them, will have some debug information. And then there's also a log that you can look at for some more details. So if we just kind of look at the unknown directory, here's the directory for the other crash ID. And again, it has the same type of files. This one's a BIE extension. But again, you have one that says minimize, and this is the one that we'll be looking for you to turn in for the PNM norm, the one that says minimized. So for this lab, in part 1, you're going to be fuzzing a common Linux utility, and that is, like I said, the PNM norm one. And we're not going to kind of give you any guidelines on how long or which fuzzers to run. This is up to you to pick. I recommend trying a bunch of different ones, but kind of use your judgment based on what they do to pick some, based on like what each fuzzer does and how it behaves and what you know about what type of file PNM norm is using to pick which fuzzers to run first. So you're going to need to update your BFF YAML file and then run the different BFF campaigns on PNM norm. So what we're going to be looking for you to submit, like I said, the minimized seed file, and then your YAML file, and the crashing output from the unique log text files. And the exact details of what you need to submit are here at the very end of the lab in the items to submit. So we're expecting you to find 2 different bugs with PNM norm, and you're going to submit your files PNM norm 1 YAML. So just rename the BFF YAML to PNM norm 1 and PNM norm 2 for the fuzzer that you used to find each specific bug, and then the corresponding unique log .text file, rename it to this format. And then PNM norm is either PPM or PGM files, so make sure you name those to pnmnorm.ppm, and these are your minimized seed file, which has the minimized in its name in your crashers directory. So that's what you're going to have to submit for part 1. And part 2 is fuzzing a C++ application, which is the CSV parser that we compiled a little bit earlier. So for this one, I should have said, like, in part 1, you're more of a tester. You don't have access to this source code. You're just kind of using what you know about the utility to select the fuzzer, and you see what the output is, and then you're submitting that to us, which is kind of like we're the developers, we're taking the seed file, and we would fix whatever the problem is. In part 2, you're more of the developer. So you have access to the source code. That's the CSV parser C++ file that you downloaded and compiled. So here you're going to have to do the same thing as in part 1, where you select which fuzzers you think will be useful, and then run the fuzzing campaign, and then look through your results in the results folder. Once you've gotten at least 2 failing test cases, there are more than 2, you're going to try to identify the cause of the bug and where this happens in the source code. So you can do this however you want to. I would recommend looking at the source code, and it's helpful, or I found it helpful, to run the seed file that's in your crashers directory directly against CSV parser from the command line and see how it behaves. And then you might also find the GDB utility helpful. And if you're not familiar with this, there's a tutorial linked from the lab that will tell you kind of how to run it and how to use it. But you don't have to use it. It's basically whatever debug method you're most comfortable with. So once you've kind of found at least 2 bugs and identified where they are in the code, we have a couple of questions for you to answer. And those are outlined here. I won't read them all to you. You can read those later. And then you'll save all of these in a responses.pdf file. So just a couple things before you get started. Make sure I read the whole lab. Make sure you know what's expected to be turned in. A common problem we have every semester is people don't name their file correctly or miss a file. They submit a zip file or something that doesn't have what they think is in there. And then when they get their grade back, it's not as good as they expect, and they don't understand why. So this is something that you can definitely control. We want you to upload all of these files in a lab1.zip. So I would highly recommend, once you've submitted it and uploaded it to Canvas, download it again and just kind of unzip it, make sure all of these files are there and named correctly, and then we can make sure that you get the credit that you deserve for the work that you put into it. So I think that's all I have to demo. If you have any questions, feel free to reach out on Piazza or our Slack office hours.